Hello, welcome to Code for Fun program for secondary school. I'm Xiang. I'm here as your trainer for today. I'll be sharing with you on the topic on computational thinking. So first and foremost, what is computational thinking? Okay, so firstly is to let you know that it is not about thinking like a computer. Okay, instead it is actually a problem-solving technique. Okay, that help you to solve problems. Okay, so can you think of times when you have a problem and you're not too sure how to approach the problem? So what computational thinking can help you to do is to teach you how to think about problems so that it's easier for you to solve. Okay, so some examples that you may already be using computational thinking. Okay, for example, planning the faster way to school, or how to plan a project, or how to create a list of steps for a recipe. Okay, so let's use this example of planning a trip. Okay, let's say, for example, you need to plan a trip. Okay, before you plan the trip, what do you need to do? Okay, you need to estimate the cost. You need to determine the best mode of transport. Okay, and all this will require to break down the problem into smaller parts and come up with a solution using logic or algorithm. Another example is maybe about excuse me, baking a cake. So when you bake a cake, you need to follow a steps. You need to follow a recipe, measure ingredient and the time that for the baking process, things like that. Okay. Okay. So let's now talk about what does computational thinking consist of. Okay. So it consists of 4 steps. Okay. So right now, what I'm going to do is to give you a very quick summary of this 4 steps before we go into details. Okay. Okay. So firstly, decomposition. So think of decomposition as breaking down a complex problem into smaller, manageable, more familiar, manageable sub-problems. So it is about breaking things down into smaller parts. Okay, next, pattern recognition. Okay, it is about reviewing how past solution can help solve similar problem. Okay, it is about looking for similarity. Okay, next is all abstraction. Okay, it's about identifying and focusing only on relevant detail that can affect the problem. Okay, so the keyword is about relevance. Okay, next, algorithm thinking. Okay, so think of it like using a sequence of steps to solve a problem. It is about looking at steps or looking at sequence. Okay, so far. Okay, now let's go into detail. Decomposition. Okay, so as I mentioned just now, decomposition is about the process of breaking down a problem into smaller, manageable parts. Okay, so by breaking things down into smaller parts, it actually makes the problems less daunting. Okay, so yeah, so this is another example. So imagine you need to you want to eat a burger. You finish a big piece of cake. What do? Do you eat it as a whole? In one big mouthful, or do you take it as small mouthful? Okay. Another example is that, okay, so this is another example, how you can make use of decomposition to solve your problem. So imagine you have a string of number to remember as what you can see on the screen here. Okay, it's 5, 4, 3, 2, 1, 8, 7, 6, 5, 4, 5, 4, 5, 4, 6. Okay, so it's basically quite a mouthful. Is there a way that you can remember better? Okay. And in this case, you can using decomposition. How do you do that? Okay, do you realize that the first few letters are in sequence? 5, 4, 3, 2, 1. After that, it starts from 8 again. 8, 7, 6, 5, 4. 5, 4. Yeah. Okay, then followed by 5, 4, 6. Okay, so do you see that it's actually 3 parts to read? Now by breaking it down, by decomposing it, it's actually easier to remember. Okay, so yeah, so all this above are about breaking the problem down into smaller parts to solve them bit by bit. Okay, so as we spoke about just now about eating the burger in one big mouthful. So this is Scooby-Doo. In the cartoon, Scooby-Doo is able to do that, but normally, we being human beings, normally we eat our burger part by part, not like what Scooby-Doo is doing here. Okay, next, pattern recognition. Okay, so over here there is actually 2 diagrams. Okay, let me ask you, what do you think that on this diagram that you're seeing on the screen here, what do you think they have in common? Okay, so the answer, yeah, if I can give you the answer, it's like, do you realize all of them can spin and all of them have round shapes? Yeah. Okay. Okay. Let's take a look at the second diagram. Okay. This is a little bit more difficult. Okay, but let me give you a hint. How are they spelled? Basically, how do you how how do you spell them? Okay. Okay. So first one is bone. Second one is bowl. Third one is boat, followed by ball, book, and boots. Do you realize they all start with B? Yeah. So as you can see, there is actually a pattern, that you can actually use to recognize, these two different sets of items. Okay, so this is pattern recognition. Okay. Okay, next, abstraction. Okay, so what is abstraction? Okay, so to better understand this, let's take a look at this picture. I just graph on this graph here. Okay, as you can see, there are actually a list of animals, on the on the graph here. Okay, so yeah, so what you can see is that so basically the question is that which detail do we focus on to figure out which animal can fly? Okay, so firstly, right, you do not need to care about the color of the bird if you want to know if it can fly, correct? Okay, never mind. That allow us to, just to decipher, this problem a bit better about abstraction. Okay, so it's about focusing only on details and taking taking out parts that do not matter. Okay, so as mentioned just now, the question is which detail do we focus on to figure which animal can fly? Do we focus on the skin color? Do we focus on the number of legs? Do we focus on the presence of wings, or do we focus on presence of the tail? Okay, if your answer is C, you got it right. Okay, so basically, do you realize that if for us to answer the question on which to focus on which animal can fly, we only need to look at the presence of wings. The other attributes are actually not relevant. Okay, so this is abstraction. Okay, lastly, algorithm thinking. Algorithm algorithm thinking. Okay, so what is this about? Okay, so it's about using a sequence of steps, which is algorithm to solve problem. Okay, for example, cooking. Some of you may be cooking, or you see your mother cooking. So this is something that make use of algorithm thinking to do the work. Okay, okay, how so? So basically, there are steps to follow, in order to perfect the final cake or the final dish. Okay. Okay, so you need to, when cooking is concerned, you need to follow the recipe step by step to ensure the ingredients are prepared to the right order and the right timing. In other words, you cannot, put, you cannot, before you mix the flour and the egg together, you shouldn't be baking it before you put the flour and the egg, right? There has to be a sequence. And the timing is important. You need to bake the cake for the right amount of time. If you put the cake for too long in the oven for too long, say 3-4 hours, what will happen to the cake? It will not turn out well. Yeah. So it's important to follow according to the order as well as the step. Okay, so here we are in the last slide. So basically this is a summary of the 4 computational thinking that we spoke about. Decomposition, which is about breaking things down into smaller parts. Pattern recognition, which is about finding things that are similar or almost similar in different objects. Okay, abstraction is about the process of taking out the details that matters and focusing on the details and not focusing on the details that do not matter. Okay, algorithms. Okay, a step-by-step a solution to solve a problem in the real world. So basically, yeah, that's all for my presentation. Thank you so much for being my audience here. Thank you.